Somewhere in the foothills of Oregon, an old sawmill still refuses to die. Every morning, its steam engine wakes with the same hiss of pressure and groan of iron heard since before World War II. This is Hull Oaks Lumber Company in Monroe, Oregon, America's last and largest commercial steam-powered sawmill. Built in 1937 by Ralph Hull and listed on the National Register of Historic Places, it still cuts Douglas fir logs up to 85 feet long and 9 feet across, dimensions that would jam most modern mills. For 3 generations, one family has kept it alive through wars, recessions, and an industry that left steam behind. This is how giant Oregon trees become timber inside a mill the modern world forgot to shut down. The forests that feed whole oaks look the way forests looked before chainsaws existed. Douglas fir, hemlock, cedar, trunks so wide you could park a car inside the stump. Some of these trees were already ancient when Columbus first crossed the Atlantic. A Douglas fir can live over 1,500 years. At that age, its heartwood becomes incredibly dense, strong enough, pound for pound, that engineers often compare it favorably to structural steel. This is the tree that built the Pacific Northwest, the railroad ties, the bridges, the ship masts, the houses, almost all of it Douglas fir. It still makes up the vast majority of timber harvested in Oregon and Washington today. But taking these trees down is not like felling a pine in somebody's backyard. A logger reads the tree before he touches it. The lean of the trunk, the weight of the crown, the way the wind is pulling. He makes one cut, and then everything that happens next is gravity and physics. If he read it wrong, the tree goes where it wants, not where he planned. In this industry, reading it wrong can be the last thing you do. Logging consistently ranks among the deadliest jobs in America, not by a small margin, but by a factor that makes most other dangerous professions look safe. And once the tree is on the ground, cut into sections, the next challenge begins. Because those sections need to travel down a mountain. Picture this, a Kenworth truck loaded with 40 tons of Douglas fir, crawling down a gravel road barely wider than the truck itself. Switchbacks so tight the trailer swings over the edge on every turn, fog rolling in, no guardrails. The legal weight limit for a log truck is 80,000 pounds. Many loads push past 88,000. That is heavier than 40 passenger cars stacked together, moving down a mountain on roads that were never designed for anything this heavy. The Cascade Range and the Rockies cut straight through logging country. Steep grades, loose gravel, snowpack in winter, wildfire, smoke in summer. Federal data shows log truck crashes in the Northwest have been climbing steadily, with fatal incidents increasing over 40% in recent study periods. Most of those deaths happen on 2-lane roads with no center barrier. The drivers know. They grip the wheel, watch the mirrors, and keep moving. Because the mill is waiting, and timber on a truck earns nothing. It only becomes money when it reaches the saw. And at the bottom of these mountains, a place that has been waiting for nearly 9 decades sits ready to receive it. You smell hull oaks before you see it, wood smoke and wet bark. Then through the trees, the outline of structures that look more like a museum than a working factory. Weathered wood, exposed steel, machines that belong in old photographs. Ralph Hull built this place in 1937, working through the winter of 38 and 39 to get it running. His grandson Todd Nystrom runs it now. 3 generations of the same family, same 28 acres in the hills near Monroe, Oregon. The Western Wood Products Association calls it possibly the last commercial steam-powered large log sawmill still operating in the country. At the center of the property, a wide pool of dark water, the log pond. This is where the trucks unload. Logs roll off the trailer and splash into water that will keep them for days, sometimes weeks, before they reach the saw. The pond is not storage, it is preparation. Water keeps the grain soft and slows the drying process. A dry log cracks and warps. A soaked log stays workable. The blade passes through it the way a knife passes through cold butter. Smooth, predictable, clean. Right now, dozens of massive logs float in that pond. Some are 9 feet across, wider than a king-size bed. No modern mill is built to handle timber this size. That is exactly why orders keep coming to Hull Oaks, jobs that no one else in the country can fill. And somewhere among those floating giants, a man on a small boat is doing a job that has existed since 1898. They call them pond monkeys. And before you think that sounds simple, watch one work. A man on a motorboat no bigger than a bathtub, holding an iron hook, steering between logs that each weigh more than his house. His job is to sort them, untangle them when they jam, and keep the flow moving without crushing anything, including himself. Was considered almost entry-level, one step above sweeping floors. But at Hull Oaks, that reputation means nothing. Here, the pond monkeys have been doing this for generations. They know how a 12,000-pound log behaves when another one bumps it. They know which end to push, how hard, and exactly when to back off. This is not strength work. It is timing, feel, and years of reading how wood and water interact. What makes pond monkeys irreplaceable is simple. No machine can do what they do. No sensor reads a logjam the way a veteran does. No algorithm tells you that the third log from the left needs a quarter turn counterclockwise to free the one behind it. This is knowledge that lives in muscle memory, passed from an older hand to a younger one, refined over decades. And it is the kind of knowledge that vanishes the day the last person carrying it decides to retire. Nobody is training replacements for this. There is no school, no certification, no manual. You learn pawn work by doing it next to someone who already knows for years until the instinct becomes yours. And even then, you are never fully done learning. When a pond monkey finally nudges the right log toward the hoist, its journey through water ends and a new chapter begins. One that starts with stripping away everything the forest put on it. Hours. So the log feeds into a ring debarker. Picture a pencil sharpener the size of a garage. A spinning ring of blades wraps around the log as it passes through, stripping bark in long, curling sheets. The knives adjust pressure on their own, following the contours of each log, handling knots and bulges without anyone touching a control. What comes off does not get thrown away. At Hull Oaks, every scrap of bark, every chip, every bit of sawdust and pond debris goes into the same place, the boiler room. The industry calls it hog fuel. It burns hot, it burns cheap, and it powers the very machines that created it. The tree that was cut yesterday fuels the saw that cuts today's tree. This closed loop has been running here since 1937, long before anyone coined the term circular economy. With its bark gone and its surface clean, the log is ready for the moment everything depends on, the first cut. Bandsaws have been doing this since 1809, when an English inventor named William Newberry patented the first one. By the 1880s, they had taken over the industry. But the bandsaw is just a tool. The person who decides where it cuts, that is the sawyer. He stands at the controls, looking at a raw log that just came off the carriage, and he reads it. The grain, the knots, the subtle twists that hint at what is happening inside where nobody can see. Then he makes the face cut, the first pass that determines everything that follows. A good read means straight, flawless boards. A bad read means tons of timber reduced to low-grade scrap. There is no undo button. There is no second chance. The sawyer reads, decides, commits, and lives with the result. The boards that come off the head rig are rough, oversized, and far from finished. They need to pass through a gauntlet of machines, and then through something no machine can replicate. Knots. One machine, then another, then another. Each pass making the wood a little closer to what a construction site needs. Streams of lumber drop off the end of the line, like cards being dealt from a deck. Then the machines stop mattering. At the end of the line, A man stands with nothing but his hands and his experience. He picks up each board, flips it, runs his palm across the grain, and taps it with his knuckle. A clean ring, strong wood. A dull thud, weakness hiding inside. This is how graders separate first-class lumber from standard grade. Not with a scanner, not with a computer. With calloused hands that have touched 100,000 boards and remember what each one felt like. Force has been beating under the mill floor for over a century.
Here you've got the doors off. You can see what the look like up down there. Oh yeah. That fire comes out. Back up.
Every night, while the town of Monroe sleeps, something stirs at Hull Oaks. Around midnight, a worker opens a valve and begins feeding the boiler. Bark, sawdust, wood scraps, everything the mill produced that day. A fire catches. Steam begins to build. By dawn, the pressure gauge reads 150 pounds per square inch. Enough force to move 8 tons of iron.
Okay, great. Thank you.
These have never been brought to the property. 4 steam engines power the very
Below the mill floor, in a space most visitors never see, sits the engine. Built in 1906 by the Ames Iron Works. 2 cylinders, each 16 inches across with an 18-inch stroke. A flywheel, 8 feet in diameter. The whole assembly weighs as much as a loaded dump truck and has not moved from this spot in over 100 years. The principle is old, but the elegance is timeless. High-pressure steam enters a cylinder. It pushes a piston. The piston turns the flywheel. A flat leather belt wraps around the flywheel and connects to a pulley above, which spins the main drive shaft. That shaft powers the bandsaw. The same belt system moves the carriage that feeds logs into the blade. One engine, one belt, one source of motion for the entire cutting floor. The idea itself, connecting a steam engine to a saw via a belt drive, became practical around 1850. Before that, mills needed rivers. After that, they could be built anywhere with wood to burn. And at Hull Oaks, there is always wood to burn. The sawdust and bark from today's cutting become tomorrow's fuel. The steam that drives the saw comes from the scraps of what the saw already cut. Nothing leaves, nothing is imported. The mill feeds itself day after day. The same way it has since Ralph Hull first fired the boiler in the winter of 1939. That rhythm, cut, collect, burn, steam, cut again, is the heartbeat of this place. But keeping that heart beating depends on another rhythm, quieter and almost invisible, happening in a room most people walk right past. No rattling chains here, no roaring carriage. Just a workbench, an anvil, a set of specialized hammers, and one man whose concentration never breaks. The filing room is the quietest place in the mill, and arguably the most important. The bandsaw blade is nearly 50 feet of steel stretched into a loop, only a few millimeters thick. It runs hundreds of passes a day through dense fur. That kind of punishment bends metal, dulls teeth, opens hairline cracks that grow into fractures if nobody catches them. The filer catches them. Every morning, he inspects the blades. He sharpens each tooth by hand, reshapes the gullets between them, and sets the angle of the kerf. When he finds a crack, he welds it before it becomes a catastrophe. When he finishes, he tensions the entire blade, a process called benching, stretching and hammering until the steel runs perfectly flat at high speed. In the trade, they call this person a saw doctor. And like a real doctor, the job demands equal parts science, intuition, and years of practice. Metallurgy, welding, mechanical diagnostics, and a feel for the metal that no textbook teaches. This trade is vanishing. British Columbia has a formal apprenticeship program for saw filers. Almost nowhere else does. In one Texas mill, the last filer retired and no replacement could be found. So, they automated the entire operation, losing decades of accumulated feel in the process. At Hull Oaks, the filing room is still staffed by a human. Every clean cut upstairs, every smooth board, all of it traces back to this room, to these hands, to knowledge that took a lifetime to build. How much longer that will last, nobody here can say for certain. That not everything at Hull Oaks becomes a 2x4. Some logs are too valuable to slice thin. Instead, the circular saw carves them into single beams, 85 feet long, weighing tens of thousands of pounds, lifted by an overhead crane that rolls on rails across the ceiling. These are the specialty orders, the jobs nobody else in the country can take on. The client list reads like a history book. Bridge engineers who need structural stringers, oldest warship, sourcing support beams from this mill. Gold dredge operators in Alaska who need timber strong enough to survive constant vibration in freezing water. And one of the most recent orders, the Ark Encounter in Kentucky, the largest timber frame structure in the United States. When someone needs a single piece of wood that nobody else can cut, they call Monroe, Oregon. For decades, the steam engine made all of this possible. But in July 2013, Todd Nystrom sat with a decision he had been avoiding for years. The boilers needed work. The engine needed parts that nobody manufactures anymore. And 65 families depended on this mill for their income. He made the call. Hull Oaks switched to electric power. The Ames engine was not scrapped. The boilers were not torn out. Everything stays where it has always been, maintained, oiled, ready. A few times each year, the crew fires up the old steam system, not because they need to, because some things earn their place just by existing, because Todd's grandfather built this mill around that engine, and as long as the building stands, the engine stays. Every board that leaves here carries something invisible with it. The weight of 3 generations, the stubbornness of a family that refused to sell, and the quiet proof that old ways of working. A tree that grew for centuries in the Oregon rain. A truck that hauled it down a road barely wide enough to survive. A man on a boat who nudged it into position with nothing but a hook and 40 years of feel. A sawyer who read its hidden structure with a glance. An engine built when Theodore Roosevelt was president, still turning a flywheel bigger than most people are tall. A filer who keeps 50-foot blades alive with a hammer and an instinct no school can teach. Most of the sawmills that once filled the Pacific Northwest are gone now. Shut down, torn apart, sold for scrap. The ones that survived did so by getting bigger, faster, more automated. Hull Oaks survived by going the other direction, by staying exactly what it was, and being so good at it that the world still needs it. It did not survive by being modern. It survived by being irreplaceable. The world moved on. The mill kept cutting.